Good morning. Today you're going to look at section 1.1. We're going to focus just on linear equations. That's what this unit is all about, is linear equations. So we're going to look at what makes it a linear equation, how do you solve a linear equation, and also some literal equations, meaning they've got multiple variables in them and we're just going to get one specific variable by itself. All right, so you can look through here. We have some vocabulary, of course. Solution or root, solution set. To solve means to find the solution. Restrictions on a variable. Basically, you just have to watch for denominators of fractions because you never want to divide by 0. So in this one, we would not want b to equal -6 or +1 because those would make the denominator 0. In this case, the denominator would be 0 if a were -5 or +2. So those are your restrictions on values of the variable. Now, there's 3 types of equations. They're categorized like this: identity, contradiction, or conditional. A conditional equation is true in one condition, like a regular equation that you're used to solving. That's one condition. There's an independent solution. Now, if they are true all the time, like the left side is exactly equal to the right side, or you'd end up with something like 0 equals 0, then that would be a dependent, not independent, but dependent solution. Notice that these two say there's probably a lot of noise in the background, but I have a dog making noise and then I have a child watching YouTube, so please excuse the background. Anyway, both of these have consistent because there is a solution. This one has every real number being the solution. This one has a specific number, but there is a solution, as opposed to this one where there is no solution. You might get something like 0 equals 1, and that's obviously not true. So it's inconsistent, okay? This one is consistent and dependent because the two sides are always together. They're always equal. And this one's consistent and independent because this is true only with one solution. Then we have our properties of equality. Of course, that means you can add and subtract and multiply and divide the same thing on both sides. Just don't divide by 0. To solve linear equations, these are first degree, degree 1, x to the first is going to make this linear. Those are just equations where it doesn't have a variable other than 1 on the, exponent on the variable other than 1. You just need to get x by itself. So in this case, you're going to just distribute and then get x's on the same side, etc. You've done all this. If you want to check solutions to linear equations, you can put the expression from the left side of the equation in y1, the expression from the right side of the equation in y2. And if you look at a graph, these will intersect when x equals the solution of these. Okay. Then you can obviously do this with fractions. My recommendation would be to get the common denominator all the way through, which would be 30 in this case, and then you can solve. There's also this note over here. If there aren't fractions, it's just easier, so get rid of your fractions. Okay. Sometimes you're going to come up with an answer that is an extraneous solution. This isn't going to happen a whole lot in this unit. That's mostly when we get to rational equations. It's definitely later in the semester. But just so you're aware, the reason we talked about variables or values that couldn't be used, way up here, where is it? Keep going. Restrictions on the variable. Okay, so that's why we talked about this, because when you're solving rational equations, you want to make sure you don't come up with one that is impossible. For example, +3 could not be true. +2 could not be true because that would make the denominator in the original problem equal 0, and that's not good. Here's one way you can solve a rational equation. Again, this is another unit, but just to give you a preview, factor everything you possibly can first and then get common denominators throughout the whole thing. And you always double check to make sure your solution is possible and not an extraneous solution. Now, here's the good stuff. We want to be able to solve formulas or literal equations. Literal because there's a lot more variables, kind of like you read literature. So what you're going to do first, you're going to focus on one specific variable. Like in this one, we're going to focus on solving for c. This is Celsius or centigrade. This is the formula for going from Celsius or centigrade over to Fahrenheit. But you can also go from Fahrenheit back to Celsius. And it's just a matter of rearranging the formula. And it's honestly, it's less work than solving for a specific value. So you start with this. Well, the first thing that needs to be done to get C by itself is to subtract 32. So it's just F minus 32. And then to get C by itself, we need to multiply by the reciprocal, which is 5/9. Ta-da! That's it. You don't have to solve anything else. No simplifying. I mean, if you wanted to, you could distribute, but you really don't have to. Here's one. This is amount of money after simple interest, or it's going to be lots of different things. This is the form that usually we'll see it anyway. But if you notice that the variable you're trying to solve for is in two places in the equation, you need to get it into one place, just one, so that you can get it by itself, just one. So we're going to factor the p out of these two terms, and then p is only being multiplied by 1 plus rt. So you just divide both sides by 1 plus rt. Ta-da! So this is especially important when the variable you're trying to isolate is in more than one location. So let's just jump right down to some of those literal equations. There's a lot of rational equations. This section is really mixed up in our book, but we're just going to pick and choose. So let's start with, let's just do one that's easy, number 75, okay? So this is perimeter of a rectangle. I want to get W by itself. That's what this means, is solve for W. So notice that we are being, it is 2L plus 2W. And I need to first subtract the 2L to move it to the other side. And then I'm going to divide by 2 to get W completely by itself. So it would be P minus 2L over 2 equals the width. If you would like, you can always divide both terms by 2. So it's P divided by 2 minus 2L divided by 2, or just L. See, that's another way to write it. Either one is just fine. But we want to really look at some where the variable is in two different places. Let's try something like this, and we'll see where this goes.
Can I put the peanuts in there?
All right. I honestly don't know what this formula is. It's probably physics. So, P sub n equals L plus S times I over F. Now, we want to get S. S by itself. So that means, let's see, what's happening to the S right now? It looks like it's being multiplied by I, then divided by F, and then adding L. So we're going to take those things off one at a time. So I'm going to start by getting rid of the L. So P sub n minus L equals S times I over F. All right, now I'm going to multiply both sides by F. And you know what? I'm just going to leave that in parentheses. I'm not going to worry about trying to distribute or anything. I mean, you can if you want, but I don't think we do. All right, so then it's chaos here. What can I say? Okay, now we're trying to get S by itself. So now we divide by I. Ta-da! And there it is. Okay? Okay, fabulous. Now let's look at number 82. So we have 1 over F equals 1 over P plus 1 over Q. Okay. We want to get common denominators throughout the entire problem. That way we won't have to worry about denominators. So this one needs F over F, as does this one. Then we need in each one, so here and here. And we need Q on each one. Whoops, you know what? I feel like I don't need one on that one, do I? There we go. Then. So they all have P, F, and Q as the denominators. So now I can dump the denominators. And I'm just dealing with 1 times P times Q equals 1 times F times Q plus 1 times F times P. Okay, now we're trying to solve for F. Notice that I have F in 2 places. So what I need to do is factor it out of these 2 terms so I have just one of them. Okay, see, there's F all alone. Well, almost all alone. We're going to divide by Q plus P, and it will be all alone. There we go. So now PQ over Q plus P equals F. Voila. These freak people out. They scare people, but I promise they're actually less work than solving most equations. They're just fewer steps. You don't have to worry about making calculation mistakes. It just is what it is. Let's do number 78, just one more. All right, so Z equals X minus, this is called mu, over, and then this is a lowercase sigma. And honestly, this is probably Z as in zeta, but we're going to go with just Z. We're trying to get mu by itself. Let's see. Mu is being subtracted from X and then divided by sigma. So I'm going to start by multiplying by sigma to get it to the other side. And now notice the X is actually the positive one, so I need to subtract it. So I have Z sigma minus X equals negative mu. The negative is still attached in front. So now what I need to do is divide by -1 to get mu totally by itself. Which what happens there, that makes the Z sigma negative and the X added. Ta-da! There we are. Hopefully that works, gives you some guidance on how to get started on those. You do have a web assignment. Oh, there's some more. I'm gonna have to do some more. But you do have a WebAssign assignment, so do please make sure that you get to that. Let's do just a couple more here, because these people think these are tricky. They're really not, but I just want to make sure that you feel comfortable with it. So how about this one? R sub 1 is what we're trying to solve for. Notice that the first fraction does not have an R sub 1 in the denominator. Now it does. And so does this one. The second fraction doesn't have an R, plain old R. There we go. And the third fraction, it has R sub 2 and nobody else does. So we're going to do that. So basically it's the same thing we did on that other problem, right? So those are gone. You have this, and now we want to get rid of, or get R sub 1 by itself. Okay, so what was that? That was equals plus. And R sub 1, oh, R sub 1 is not both of them on the same side. So we need to get them on the same side first. I'm going to subtract this one. So, and you know, be careful, because if you're, I think it's easier to just consistently use the same colors. That's why I try to make them colorful. Okay, so then I used orange for our, let's just do that. Let's try to keep consistent. Okay, so then I have these. Okay, like so. And it's gonna equal, whoops, not that, just kidding. It's gonna equal this. And then we need to distribute, or excuse me, factor. We're gonna undistribute.
Mom, check what's in the chest.
I'm being attacked by a creeper. You never know when that's going to happen. Okay, there we go. Oh, and, you know, obviously don't forget your parentheses. So I factored out the R sub 1, And now I can divide both sides by the r sub 2 minus r. That's not what I want to do. Do this. Yay, copy paste. Okay, lovely. And so then we got this. Ta-da! Isn't that cool? I love these. So anyway, again, make sure that you go to WebAssign and do your homework assignment, please. You will find it. Make sure you'll go through Cengage to click into WebAssign. So click on the assignment for 1.1. This is 1.1 linear equations. All right. Have a great day.